All right, we got homework 10.1. We are to express each of the following in simplest form in terms of only sine and cosine. So that means the only trig functions that can be in our answer have to be sine and cosine. So lots of ways to do these problems, lots of correct ways, so this is not the only way. So I could take this and I could say that cotangent of x divided by cosecant is the same as cotangent of x times 1 over cosecant of x. Just basically breaking apart that fraction. Cotangent of x is cosine of x over sine of x. 1 over cosecant of x, its reciprocal, is sine of x. Sine of x's cancel, and we're left with cosine of x. That's as simple as we can make it, and it's in terms of cosine. Number 2. I can do this one in a very similar way. I can say this is the same as tangent of theta times 1 over secant of theta. And I can say that tangent is the same as sine of theta over cosine of theta, and 1 over secant of theta is the same as cosine of theta. Multiplying and dividing by the same thing, so they cancel, we end up with sine of theta. Number 3, this feels like the same problem I just did, essentially. Secant is 1 over cosine of x. Tangent is sine of x divided by cosine of x. I could then multiply the fractions together. Once again, the direction said, oh, I misread the directions. The directions say we need to get in terms of sine or cosine, which means our answer has to just have sines in it or just cosines. So this is not finished because this has some cosines in the problem. I hope you recall that cosine squared of x is the same as 1 minus sine squared of x. Let me prove that to you real quickly with some side work. Pythagorean identity, sine squared of x plus cosine squared of x equals 1. If I get cosecant squared by itself, I would subtract sine squared from both sides. So we can leave the answer like this because it's in terms of sine only. Number 4, the directions, get this in all in terms of sine or cosine. So let's see, I will change things in terms of sine and cosine. The numerator, I'm going to change cotangent to cosine of theta over sine of theta. I'm going to change the 1 so it has a common denominator as the fraction on the right. And the bottom is already of sine and cosine, so I'll leave that the same. Now my numerator, I have the same denominators, so I can add the numerators together. And now, as a complex fraction, to get rid of the denominator of sine of theta, I'm going to multiply this by 1 in the form of sine of theta over sine of theta. Those sine of thetas cancel. So now we have sine of theta plus cosine of theta over sine of theta plus cosine of theta times sine of theta. We're multiplying the top and bottom by sine of theta plus cosine of theta, so those cancel. So we end up with 1 over sine of theta. The direction said the answer has to be in terms of sine or cosine, and we have accomplished it being in terms of sine. Number 5, these directions are the same. I'm going to multiply these two binomials together. They are conjugates. When you multiply two conjugates together, you get the first term squared minus the last term squared. Let me just remind you how that works. We got 1 times 1, which is 1. We have 1 times cosine of x, that's cosine of theta. We have 1 negative cosine of theta times 1, that's a negative cosine of theta. So those cancel. Then we have negative cosine times positive cosine of theta, that's going to be cosine squared. Well, this is sine squared. And once again, that comes from the fact that sine squared of theta plus cosine squared of theta is 1. If you subtract cosine squared from both sides, you get sine squared of theta is 1 minus cosine squared of theta. Side work, this is optional for this. And then we can change cosecant. I miswrote this. We can write cosecant of theta as 1 over sine of theta. We can cancel a sine from the top and the bottom, and then this just equals sine of theta. All right, these next directions are different. Express each of the following in terms of a single trig ratio. So it doesn't have to be sine or cosine now. It can be anything. So let's see, if we distribute this using the distributive property, secant of alpha times cosine of alpha, those are inverse operations. They're reciprocals, I should say. If you multiply two reciprocals, you get 1. If I multiply secant of alpha times secant of alpha in the second term, I'm going to get secant squared of alpha. Then if I change secant squared into its reciprocal, I'm going to get 1 over cosine squared of alpha. This becomes 1 plus sine squared of alpha over cosine squared of alpha. Sine over cosine is tangent, therefore sine squared of alpha over cosine squared of alpha is tangent squared. Now this looks familiar. This is one of the Pythagorean identities. This is equal to secant squared. All right, it's in terms of a single trig ratio. It's in terms of secant, so we're finished. Problem's done. This next one, number 7. Let's see. I'm going to distribute this like we did on the previous one. It's going to give me cosecant squared of theta plus cosecant of theta times cotangent of theta. Then I'm going to change everything in terms of sine and cosine, because that's usually a good plan if nothing seems obvious. And right now, nothing seems obvious. So that's going to give me 1 plus cosine of theta over sine squared of theta. Pay attention to what's going to happen next, because it's pretty epic. Somehow this has to become in terms of only one trig function, sine or cosine, tangent or cotangent, secant or cosecant. Right now we have sines and cosines in it. So I'm going to remind you of what the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. If I subtract cosine squared from both sides, I get sine squared of theta is 1 minus cosine squared of theta. So I'm going to replace the denominator with 1 minus cosine squared of theta. Now this is only in one trig function now, which is great, but it's not all the way simplified. Here's why it's not all the way simplified. The denominator is a difference of two squares. It factors into a 1 minus cosine of theta times its conjugate 1 plus cosine of theta. We are now multiplying the top and bottom by the same thing, 1 plus cosine of theta. And that leaves us with the simplest form we can get, 1 divided by cosine of theta. So in terms of one trig function, simple as we can get it, so that problem is finished. Number 8. Let's see. I'm probably going to change this into terms of sine and cosine. That is a good option for the vast majority of problems. To make a common denominator with sine of theta and 1 over sine of theta, I'm going to multiply the top and bottom of this fraction by sine. It's going to give me sine squared over sine. This is over cosine of theta. This is going to give me 1 minus sine squared of theta over sine of theta over cosine of theta. Then we can replace, well, before I replace, let's make this not a complex fraction. I'm going to multiply this by 1 in the form of sine over sine so that those signs cancel. That's going to give me 1 minus sine squared of theta over sine of theta cosine of theta. Now this numerator comes from the first Pythagorean identity. I can replace that with cosine squared of theta. Very similar reason that we did this one up here. Then I can cancel from the top and the bottom of the fraction 1 of the cosine of thetas. So it leaves me on top cosine of theta over sine of theta. If the directions were different, where it said leave your answer in terms of sine and cosine, we'd be done. If it said sine or cosine, we wouldn't be done because it says that would be one trig function. This direction say leave it in terms of one trig function. This is equal to cotangent of theta. So now we're finished with it. Number 9, I recognize right away that my denominator is equal to sine squared of theta. That's from the first Pythagorean identity solved for sine squared. I can cancel a sine squared from the top, or a sine from the top and the bottom, leaving me with cosine of theta over sine of theta, and this is cotangent of theta. Awesome. Number 10, I will get rid of my parentheses first by distributing. I get sine of beta times cosine of beta plus sine squared of beta tangent of beta. Then I will change this to in terms of sine over cosine, see what happens. Right now I don't know what's going to happen. It's going to make this tangent of beta sine of beta over cosine of beta. Now this is all going to become one fraction with the denominator of cosine. So I want this to have a denominator of cosine. So to do that, I'm going to put cosine on the bottom. Got to multiply it by the top. It's going to give me cosine squared. Once you have common denominators, add the numerators. We get this, which appears to be like, how could this possibly help us? Well, let me tell you how. There's a GCF in the numerator. Both of these terms have a sign of B in them, sine of beta. If we factor that out to the front, we're going to get cosine squared of beta plus sine squared of beta in the numerator. I hope you know what that is. This is equivalent to 1. So this is going to be sine of beta times 1 times cosine of beta. Sine of beta divided by cosine of beta is tangent of beta. Finished. Number 11, I'll distribute first and get cosecant of x times secant of x minus cosecant of x cosine of x. I will now change these three things to be in terms of sine and cosine and see what that does for me. So that's going to give me 1 over sine of x cosine of x, and this is going to be 1 over sine of x times cosine of x. To get common denominators, I need this fraction to have a cosine on the bottom. So I'm going to multiply this by cosine over cosine. That's going to give us one fraction, 1 minus cosine squared of x over sine of x cosine of x. I think we played this tune before. 1 minus cosine squared of x is sine squared of x. That comes from the first Pythagorean identity, solved for sine squared. Then we can cancel from the numerator a sine of x and from the denominator a sine of x. That gives us sine of x over cosine of x, which of course is tangent of x. Awesome. Got 2 more problems. Number 12. I would like to add these together, so I'm going to change tangent to sine over cosine. These are supposed to be thetas, not x's. There are 2 fractions I'm trying to add together, so I need common denominators. I'm going to multiply this fraction by 1 in the form of 1 plus sine of theta over 1 plus sine of theta. I'm going to multiply this fraction on the left by 1 in the form of cosine of theta over cosine of theta. That's going to give me cosine squared of theta plus, if I distribute the sine, sine of theta plus sine squared of theta. My denominator, I'm not going to multiply it out, because I think it's going to be better if I don't, so we'll see. Now my numerator, cosine of theta plus sine squared of theta, that's 1. My denominator has a similar factor of 1 plus sine of theta. This is the entire top, and this is a factor on the bottom. We can cancel those and get 1 over cosine of theta. And that, the direction said, leave your answer in terms of one trig function. So we're going to leave that as secant of theta. All right, last one. Simplify the expression completely. So we don't know what the answer is going to look like. Could be one trig function, could be multiple, could just be a number. Let's see what happens. I will start by making this one fraction and see what happens. To do that, I'm going to multiply this fraction by 1 in the form of 1 over 1 plus secant of theta over 1 plus secant of theta. And I will multiply this first fraction by 1 in the form of 1 plus cosine of theta over 1 plus cosine of theta. So that's going to equal, I'm going to distribute this while I'm doing this. So I'm going to have cosecant of theta plus cosecant of theta times cosine of theta. And I'm subtracting from that, distributing this cotangent. This subtraction here is the most important part of this problem, meaning the part people are most likely to make mistakes. I have cotangent of theta plus secant of theta times cotangent of theta. This is all going to be over 1 plus secant of theta times 1 plus cosine of theta. I don't know if that bottom needs multiplied out yet. I'm going to leave it there and see what happens. Maybe I won't have to do anything with that. We'll see. My numerator, I'm going to change things in terms of sine and cosine. So I'm going to have 1 over sine of theta plus cosine of theta over sine of theta, distributing this minus cosine of theta over sine of theta. Hey, it looks like we're going to have common denominators. Plus 1 over cosine of theta times cosine of theta sine of theta. Awesome. And then let's not forget about my denominator, which at this point, I'm not sure if I need to change it or not. I'm just going to leave it and see what happens. I might have to change it. Now, in this last term, these cosines cancel. So I have 4 fractions on the top. They already have common denominators. So it's going to be 1 plus cosine of theta minus cosine of theta plus 1 over sine of theta over this denominator, which I'm not sure what I'm going to do with that yet. Oh, check this out. 1, is that plus? I'm sorry, I guess I can't cancel that. 1 plus a 1? I made a mistake, yo. Made a mistake up here. If I distribute this minus, this is the part I said it was the part people make mistakes on, then I made a mistake on it. That makes this a minus, which makes this a minus 1. I'd like to say that I made that mistake on purpose for emphasis, but I didn't. I was careless. You got to be real careful about that negative. So 1 minus 1 cancels, gives us 0. Cosine of theta minus cosine of theta also gives us 0. We can stop simplifying this because this is 0 divided by sine of theta, which is 0, divided by this other thing, it's still going to be 0. So that simplifies to just 0. That concludes the homework.